A dwarf planet 4 billion miles away just handed astronomers a signal that, according to every model they own, should not exist. Somewhere in the freezing haze above Pluto's surface and somewhere in the thick orange atmosphere of a moon orbiting an entirely different planet, there's a chemical fingerprint that matches nothing in any laboratory record, any database, any published spectrum ever collected. Not a known gas, not a known ice, not anything currently on the periodic table's long list of confirmed molecular combinations. Just a dark, unexplained notch in the light bouncing back from two of the coldest, strangest worlds in our solar system. Stick around, because I'm about to walk you through exactly what scientists just found, why it genuinely should not be possible under the models we currently have, and why the same signal showing up on two completely different worlds is making researchers rewrite their assumptions in real time. And hit subscribe now, because this channel breaks down real space discoveries without the exaggeration, and you do not want to miss what else is coming out of the outer solar system. Let's go back to where this story actually begins, because Pluto's history is stranger than most people remember. In 1930, a 24-year-old assistant named Clyde Tombaugh, working at an observatory outside Flagstaff, Arizona, was given one of the most tedious jobs imaginable. He photographed the same patch of night sky on different nights, then flipped back and forth between the plates, searching for a single point of light that had shifted position against the fixed stars behind it. Most nights produced nothing. Then, on one plate in February of that year, something moved, and that tiny shifting dot became Pluto. For most of the century that followed, it held the title of the 9th planet in our solar system, even though it was so distant and so small that astronomers could only guess at what it actually looked like up close. Then, in 2006, the International Astronomical Union held a vote and formally reclassified Pluto as a dwarf planet, stripping it of the title that had made it famous, making it the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the very category that once defined it. For a while, that felt like the end of the story. Pluto was small, distant, and easy to file away as unimportant. That assumption did not survive contact with real data. In July of 2015, after a journey lasting 9.5 years across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles an hour. It had exactly one chance, no orbit, no second pass, just a narrow window of a few minutes to capture as much as it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back completely rewired what scientists thought they knew. A massive, pale, heart-shaped plane stretched across the surface, smooth and strangely young-looking compared to the ancient, heavily cratered terrain surrounding it. Mountains built from solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like solid rock. And layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the sun, far higher and more intricate than any model had predicted before the flyby. Pluto did not look like a leftover chunk of frozen rock. It looked like a world, still in the process of becoming something. But New Horizons only got one look. Whatever it missed on that single pass would remain a mystery for years, because there was no way to send another spacecraft, and no way to test the theories scientists were building except by waiting for a better instrument to come along. That instrument turned out to be the James Webb Space Telescope, and it works nothing like a flyby spacecraft. Webb does not fly past anything and snap a picture. Instead, it reads light itself, breaking it apart into its individual wavelengths to reveal the precise chemical fingerprint of whatever it happens to be staring at. Pointed at a faint pinprick of reflected sunlight billions of miles away, it can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how that atmosphere is behaving over time, all without physically traveling anywhere. But there was a specific technical problem standing in the way of using Webb on Pluto, and it took years to solve. Pluto and its largest moon, Charon, sit so close together in the sky from Webb's point of view that separating their individual L-thermal signals was, for a long time, practically impossible. As the astronomer Tanguy Bertrand at the Paris Observatory later explained, researchers simply could not tell how much of any detected heat was coming from Pluto itself and how much was bleeding in from Charon sitting nearby. It was not until 2022, once Webb's instruments were fully calibrated and its far larger mirror and far more sensitive infrared detectors came fully online, that scientists were finally able to cleanly separate the two signals for the first time. Once that separation became possible, one of the very first mysteries Webb helped confirm involved a theory that had been sitting untested since 2017. A planetary scientist named Shi Zhang, working at the University of California, Santa Cruz, had proposed something that sounded almost backwards at the time. On Saturn's moon, Titan, atmospheric haze traps heat and warms the world below it. Zhang argued that Pluto's haze might be doing the exact opposite. absorbing sunlight during the day and then radiating that energy straight back out into space, as infrared heat, faster than Pluto's extremely thin atmosphere, could ever hold on to it. In effect, the haze would not be acting like a blanket. It would be acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, there was no instrument sensitive enough to actually test that idea. Once Webb's mid-infrared instrument, known as MIRI, became capable of resolving Pluto separately from Charon, Bertrand's team used it to measure Pluto's atmosphere directly, in what researchers describe as the first mid-infrared spectrum ever obtained of the Pluto-Charon system, spanning wavelengths that had simply never been explored there before due to the limitations of earlier instruments. The results, published in the journal Nature Astronomy, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended within it, roughly 30 degrees Fahrenheit colder than earlier models had expected. As Bertrand put it plainly, this is unique in the solar system, and Zhang, hearing his own prediction validated years later, noted that in planetary science, it is not common to have a hypothesis confirmed so quickly. That discovery alone would have been enough to make Pluto worth another look. But it turns out that was only the opening chapter of what Webb would eventually find there, because the same team, working with the same mid-infrared data, ran into something they were not looking for and could not immediately explain. While analyzing the detailed spectrum of Saturn's giant moon Titan, a completely different world in a completely different part of the solar system, a research group led by the astronomer B. Bézard noticed an unexpected absorption feature centered at a very specific wavelength, 5.1113 micrometers, cutting a clean 6 to 7% dip into the light, reflecting back from Titan's surface. That in itself was strange enough. Titan is enormous compared to Pluto, actually larger than the planet Mercury, wrapped in a dense nitrogen and methane atmosphere with a surface pressure about 50 times that of Earth, and famous for being the only other place in the solar system besides Earth known to have liquid rivers and seas, in Titan's case made of liquid methane and ethane rather than water. Researchers compared the signal against radiative transfer models built from every known gas and haze particle in Titan's atmosphere, and the absorption simply did not appear anywhere in the simulations. It did not behave like a typical atmospheric absorption line either. It was broader than the sharp, narrow shape you would expect from a specific molecule's vibrational signature, and when the team compared the spectrum at the center of Titan's visible disk against the spectrum near its edges, they found the opposite of what atmospheric absorption should produce. If the signal were coming from gas in the atmosphere, it should have grown stronger toward the edges, where light has to pass through more air to reach the telescope. Instead, it grew weaker. That told the researchers the signal was not atmospheric at all. It was coming from the surface itself, some unidentified solid material sitting on Titan's ground, absorbing light at a wavelength nothing in their reference library could account for. Here is where the story becomes genuinely strange. Because when the same research team went back and checked Webb's existing archived observations of Pluto, collected in May of 2023, they found the identical signal sitting in Pluto's spectrum as well. The same 5.113 micrometer absorption on a completely different world 4 times farther from the sun than Titan is, roughly half Titan's size, with a surface temperature colder than almost anywhere else humans have ever measured, and a bulk composition that shares only the barest overlap with Titan's chemistry, mostly nitrogen and methane ices rather than Titan's dense churning atmosphere. On Pluto, the same absorption feature was measured at a similar depth, around 4 to 5%, but it was roughly 3 times wider than the version found on Titan, suggesting that whatever the underlying molecule is, it is likely far more abundant on Pluto's surface than on Titan's. And on Titan specifically, the researchers noticed something even stranger, layered on top of that. The signal was unevenly distributed across the moon, showing up more strongly on Titan's trailing hemisphere, the side of the moon that faces backward relative to its direction of travel around Saturn, than on its leading hemisphere. That kind of lopsided distribution usually points towards some kind of external process altering the surface unevenly, similar to the way charged particles trapped in a planet's magnetic field can bombard one side of an orbiting moon more heavily than the other. The research team did exactly what careful scientists are supposed to do when they find something that does not match anything in their reference material. They went back through the published scientific literature and systematically compared the observed signal against the known absorption spectra of essentially every compound that has ever been confirmed in the atmospheres or surface ices of Titan and Pluto, including ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, and a long list of other hydrocarbons and nitriles that show up in these frigid, methane-rich environments. According to the researchers' own published conclusion, none of the bands reported in any of that prior literature corresponds to the location of the absorption they were seeing. In their own words, this is not a subtle mismatch buried in statistical noise. It is a clean, measurable gap in the light, where no currently known molecule is supposed to produce one. The team has proposed a short list of plausible candidates that deserve further investigation, including alans, a class of organic compounds with a particular double-bonded carbon structure that produces absorption features in roughly the right region of the spectrum, as well as benzene mixed with other unidentified molecular species, or possibly some form of frozen acetylene or ketene ice altered by exposure to extreme cold and radiation over long timescales. But by their own admission, none of these candidates has been confirmed, and the researchers describe this as an open question requiring substantially more laboratory work before anyone can say with confidence exactly what is sitting on the surfaces of these two worlds. Sit with that for a second, because this is the part that tends to get lost in a headline. Two worlds, separated by roughly 900 million miles, with wildly different sizes, wildly different atmospheres, wildly different thermal histories, and only the loosest chemical overlap in the nitrogen and methane ices they both happen to share, are producing the exact same unexplained signal at the exact same wavelength. That is not the kind of coincidence working scientists take lightly. It suggests either that some shared physical process, extreme cold combined with billions of years of exposure to sunlight and cosmic radiation, is independently manufacturing the same exotic molecule on both surfaces through parallel chemistry, or that this particular compound, whatever it turns out to be, is simply a far more common byproduct of icy, methane-rich environments throughout the outer solar system than anyone previously assumed. Either explanation means there's a piece of basic organic chemistry happening in the coldest regions of our solar system that current models simply did not anticipate, and it took an instrument as sensitive as Webb's Miri spectrometer just to notice the gap in the first place, since earlier telescopes never had the resolution or the sensitivity to separate a signal this faint from the noise surrounding it. This new mystery sits on top of a body of chemistry that scientists had already been slowly piecing together on Pluto for years. Even the extremely faint trickle of sunlight that reaches Pluto, roughly 1,000 times weaker than what reaches Earth, is enough to break apart methane molecules high up in its atmosphere. Those broken fragments do not simply vanish. They recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles known as tholins, which drift downward and settle onto the surface below. New Horizons caught early traces of this process back in 2015, and researchers have continued refining exactly how it unfolds ever since. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially contributing raw material for the kind of chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years. A slow, continuous snowfall of biological building blocks, landing on a surface too frozen for any of it to ever spark into something alive. Surface temperatures on Pluto generally sit somewhere between about -387 and -369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. Cold enough that nitrogen, the same gas that makes up most of the air in your lungs right now, would freeze completely solid and become part of the landscape. That same slow leak of atmosphere off of Pluto turns out to be connected to yet another mystery involving its largest companion moon, Charon, a battered ice world roughly 750 miles across that orbits in an extremely tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, ancient and heavily cratered, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. Researchers eventually confirmed that Charon's slow, extremely long seasons are responsible. Because of how Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time, turning that pole into an extremely effective cold trap where escaping methane molecules from Pluto's atmosphere drift across roughly 12,000 miles of space, freeze solid onto the surface, and sit there accumulating for years before sunlight finally returns. When it does, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier, more complex reddish compounds, essentially locking in that dark coloring permanently. In October of 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide and hydrogen peroxide frozen directly onto Charon's surface, a specific combination of frozen chemicals that had never been confirmed there before, adding yet another layer to a moon that keeps turning out to be far more chemically complex than its plain icy appearance would ever suggest. It helps to picture, for just a moment, what it would actually mean to stand where this unidentified material is sitting, because the environment producing it is almost impossible to imagine from anywhere on Earth. On Pluto, the sun appears only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth and no meaningful glare, faint enough that you could look directly at it without discomfort. The sky around it sits in a permanent grayish-blue gloom, thick with the very haze that Webb has now confirmed is actively refrigerating the world beneath it, never fully day and never fully night, just an unchanging dimness stretched across an atmosphere roughly 100,000 times thinner than Earth's. The ground itself would not behave anything like ice does here. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. Somewhere within that frozen, hazy landscape, according to the new spectra, sits a molecule nobody has identified yet, embedded in the surface itself rather than floating in the thin air above it, patiently absorbing a very specific wavelength of light for reasons scientists are still working out. The fact that the same unexplained fingerprint turned up on Titan only deepens how strange this actually is, because Titan could hardly be a more different environment. Where Pluto's atmosphere is a wisp, barely there at all, Titan's is thick and heavy, with a surface pressure about 50 times greater than Earth's, dense enough that a person standing on its surface, wrapped against the toxic cold, could, in principle, strap on wings and glide through it. Titan has weather. It has methane rain falling from orange skies, river channels carved into its surface by liquid hydrocarbons, and entire seas of liquid methane and ethane pooling near its poles, features found nowhere else in the solar system besides Earth's own water cycle, for a compound. To leave the same chemical signature on a world with rivers and rain as it does on a nearly airless, refrigerated dwarf planet 4 times farther from the sun suggests whatever process is creating, it does not depend on the specific details of either atmosphere. It depends on something more, fundamental perhaps, the raw combination of methane, nitrogen, extreme cold, and billions of years of exposure to sunlight and cosmic radiation that both worlds happen to share, even though almost nothing else about them matches. All of this chemistry, the haze that refrigerates Pluto's sky, the tholins raining down for billions of years, the methane leaking across space to stain Charon's poles, and now this unidentified molecule showing up identically on 2 unrelated worlds, points toward something scientists find genuinely significant well beyond simple curiosity. Researchers studying the origins of life on Earth have long debated where the first organic building blocks actually came from, whether they formed here on the early planet itself or arrived from space, carried in by comets, asteroids, or slow chemical processes happening in distant icy environments, similar to what we now see happening on Pluto and Titan. Studying a real ongoing example of that chemistry, running continuously for billions of years on nearby worlds, gives researchers something they could not get any other way, an active natural laboratory for a process that on Earth finished playing out and left behind only indirect evidence billions of years ago. As Jung himself put it, studying Pluto's haze and chemistry might offer new insights into the conditions that made early Earth habitable in the first place. There is no funded mission currently planned to send another spacecraft back to Pluto to investigate any of this directly. No lander, no orbiter, nothing on the books, largely because the journey alone would take the better part of a decade. And outer solar system exploration has rarely been treated as a funding priority compared to missions closer to home that can return results within just a few years. For the time being, Webb remains the only working tool capable of studying these worlds in this kind of detail, quietly checking back in every so often whenever Pluto or Titan swing back into its field of view, adding another data point each time, and, as this latest discovery shows, almost always making the overall picture stranger than it was before rather than simpler. Pluto sits inside the Kuiper Belt, a vast ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects wider than 60 miles along with an estimated trillion or more comets, an area of space hundreds of times larger than the asteroid belt between Mars and Jupiter and almost entirely unexplored. If 2 worlds as different as a small, nitrogen-frosted dwarf planet and a giant, river-carved moon of Saturn can independently turn up the exact same unidentified chemical signature the moment we finally had an instrument sensitive enough to look closely, there is no obvious reason to assume they are the only 2 places in that vast, frozen region hiding something like it. So what does all of this actually add up to? A signal that current models say should not be there, sitting in the spectra of 2 of the strangest worlds humanity has ever studied up close, discovered almost by accident, while scientists were confirming an entirely different theory about Pluto's haze acting as a natural refrigerator for its own atmosphere. Researchers have real, testable candidates in mind: allenes, modified benzene compounds, unusual ices of acetylene or ketone, but they are honest that none of it is confirmed yet, and that meaningfully, more laboratory work is needed before this particular gap in the light gets a name. That is what real, careful planetary science looks like when it runs into something genuinely new, Not a dramatic reveal wrapped up in a single headline, but a careful, published, peer-reviewed admission that there is a piece of chemistry out past the orbit of Neptune that nobody has identified. Yet, showing up in the same place on two unrelated worlds, and that the only instrument currently capable of studying it in enough detail to even notice the gap is quietly pointed back at both of them every few months, adding one small piece to a puzzle that keeps getting stranger the closer we actually look. If stories like this one, grounded in real published research rather than exaggerated headlines, are what you want more of, subscribe to this channel and turn on notifications, because Webb is still watching Pluto and Titan. And there's a real chance the next round of data finally puts a name to whatever this is.